This is a video from section 3.10. The differential dy is defined in terms of dx by the equation dy is f prime of x dx. The directions say to find the differential of the given function. And we're going to start off with problem number 11. Suppose y equals e to the 5x. And we want dy. Well, the derivative of e to the 5x with respect to x is e to the 5x times the derivative of 5x with respect to x, which is 5. Remember, that's just chain rule. And then notice over here, we have to attach a dx here, okay? And so we're going to take this and attach a dx. And so, therefore, dy is equal to 5e to the 5x dx. And one thing I would like to point out is this notation is not going away. You will encounter this notation again when you reach chapter 5. So this is something I would really learn well. Okay? Now, let's take a look at number 12. Suppose y equals square root of 1 minus t to the 4th. And so, therefore, y equals 1 minus t to the 4th to the half, okay? And so if I want dy, I'm going to take the derivative of 1 minus t to the 4th to the half with respect to t. So if I apply the chain rule, I get 1/2 times 1 minus t to the 4th raised to the negative 1/2. And I need to multiply by the derivative of the inside function with respect to t, which is negative 4t to the 3rd. But remember, we have to attach a dt. We're looking for the differential of this function. So y is expressed in terms of t this time and not x. And so if we simplify this a bit, now 2 goes into 4 2 times, and so we get negative 2t to the 3rd divided by 1 minus t to the 4th to the half dt. And I'll just make one more step. We'll say dy is negative 2t to the 3rd divided by the square root of 1 minus t to the 4th dt. And we just found the differential of the given function. And that's number 12. If we take a look at number 13, suppose y is equal to 1 plus 2u divided by 1 plus 3u. And we want dy. So we need to differentiate this function with respect to u. So we need to apply the quotient rule. So I'm going to take 1 plus 3u, that's the denominator. I'm going to multiply by the derivative of the numerator, which is 2. I'm going to subtract 1 plus 2u, that's the numerator, times the derivative of the denominator, which is 3. And I'm going to divide by 1 plus 3u raised to the 2nd. And then remember, we're looking for the differential, so I need to attach a du at the end. And again, I can't stress enough how important this notation is. You're going to see it again, and the first place you're going to encounter it is chapter 5. Okay? Now, dy. Let's do a little simplifying here. So I'm going to distribute the 2 in, and so I get 2 plus 6u minus, and then I'm going to get 3 plus 6u for the numerator. And I'm going to divide by 1 plus 3u to the second du. And so dy is 2 plus 6u, and then I need to distribute the negative inside, and so I get minus 3 minus 6u divided by 1 plus 3u raised to the second du. But these 6u's are going to cancel, and 2 minus 3 is negative 1. And so dy is negative 1 divided by 1 plus 3u raised to the second du. And that's number 13. If we take a look at 14, suppose y equals theta raised to the second times sine 2 theta, and we need to find dy. So we have to do the product rule here. So I'm going to write down the first function, which is theta squared. I'm going to multiply by the derivative of the second function, which ends up being, by the chain rule, the derivative of the sine function is the cosine function. So we're going to get cosine of 2 theta times the derivative of the inside function, which with respect to theta, which is 2, like this. And then I'm going to add sine 2 theta. That's the second function, and I'm going to multiply by the derivative of the first function, which is 2 theta. And this whole thing, with this whole thing, we need to attach a d theta here. So I'm going to put it right there. And so dy is 2 theta squared cosine 2 theta plus 2 theta sine 2 theta d theta. And that would be dy. And I would leave it to your instructor if your instructor wants you to factor out a 2 theta from this or leave the 2 theta inside. I would leave it to your instructor, but in essence, this is how you find the differential for this particular function. And that's problem number 14. If we take a look at problem 15, suppose y equals 1 over x squared minus 3x, which is x squared minus 3x to the negative 1, and I want dy. So that's negative 1 times x squared minus 3x raised to the negative 2 times the derivative of the inside function with respect to x, which is 2x minus 3, and then I'm just going to attach a dx here, okay? And so this is negative of 2x minus 3 divided by x squared minus 3x raised to the second power dx. And I'm going to put the dy here. And so that's what the answer to 15 would be. If we take a look at 16, suppose y equals the square root of 1 plus cosine theta, which is equal to 1 plus cosine theta raised to the half, okay? And I want dy. So this is classic chain rule. It's half of cosine theta plus 1, or 1 plus cosine theta, to the negative 1/2 times the derivative of the inside function with respect to theta. Well, that's negative sine theta, and then I have to just attach a d theta here. And so therefore dy is negative sine theta divided by 2 times the square root of, if you don't mind, 1 plus cosine theta d theta. That's problem 16. If we take a look at problem 17, suppose y equals natural log of sine theta. So dy, by the chain rule, we get 1 over sine theta times cosine theta, and then just attach that d theta there. Okay? And so dy is, now cosine theta over sine theta is cotangent theta. So we get dy is cotangent theta d theta. And that's the differential for the function y equals natural log of sine theta. And then lastly is problem 18, and that's the last one for this video here. Suppose y equals e to the x divided by 1 minus e to the x, and I want dy. Well, to find the derivative here, I need to apply the quotient rule. So we're going to write down the denominator, which is 1 minus e to the x. I'm going to multiply by the derivative of the numerator, which is e to the x, minus, write down the numerator, which is e to the x, and then I'm going to multiply by the derivative of the denominator, which is negative e to the x, and then I'm going to divide by 1 minus e to the x to the second. And remember, we still have to attach that dx at the end. It's very important notation that we're doing here. So dy is e to the x minus e to the 2x plus e to the 2x divided by 1 minus e to the x squared dx. E to the 2x's cancel, and therefore dy is e to the x over 1 minus e to the x squared dx, and that'll conclude this video for section 3.10, and we worked problems 11 through 18. Okay. Thank you.